NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Now entering an enigmatic and uncharted area of space, Voyager 1, which was launched over 40 years ago, is revealing truths that even the most seasoned scientists find unnerving. Built with less sophisticated technology, this ancient spaceship is still traveling billions of kilometers away from Earth. It challenges our understanding of the cosmos by presenting us with discoveries as it goes into the unknown. What bizarre truths lurk in these depths of space? Get ready as we examine the startling discoveries made by Voyager 1. A 45-year odyssey beyond the stars, just when you think the story would end in quiet, it surprises us with signals that outsmart our advanced technical capabilities. This mission, which was founded in 1977, has broken boundaries rather than merely expanding them. A terrifying revelation that redefines the impossible is about to unfold. Get ready. What is in store for Voyager 1? Keep checking back when we learn more. Something amazing occurred in the field of space exploration back in 1965. Two spacecraft were ready to set out on a journey that would alter the course of history. Flandro, a gifted engineer at NASA's Jet Propulsion Laboratory, faced a difficult task at the dawn of the space era. He had to determine the most direct route for a spaceship to travel in order to reach Jupiter, Saturn, Uranus, and Neptune, the far-off gas giants. With just a pencil in hand, Flandro made an important discovery. He understood that all four planets will line up precisely in the sky in the late 1970s and early 1980s, forming a unique cosmic route. Because of this arrangement, a spaceship may travel from Earth to Neptune in just 12 years as opposed to the customary 30 by utilizing the gravitational pull of each planet. But given this alignment only occurs once every 176 years, it was a once-in-a-lifetime chance. NASA realized they needed to move quickly. These missions were scheduled in such a way as to maximize this special planetary lineup. Nobody anticipated that these probes would go on to become historical landmarks. Voyager 1 and Voyager 2 are still orbiting the planet more than 40 years later, having traveled further than any other spacecraft. They keep returning insightful data that broadens our understanding of the cosmos and reveals fresh surprises. More than anybody could have predicted, these devices have endured far longer and traveled far farther. They were only meant to work for 4 years at first, but they have worked considerably longer than that. They have continuously amazed us along the way. Initially, they returned breathtaking images of Jupiter and Saturn's moons, revealing to us that these far-off worlds are considerably livelier and more vibrant than we could have ever anticipated. We witnessed ice fields moving and volcanoes erupting, drastically altering our perception of these distant worlds. Leading the way in this investigation was Voyager 2, which in 1986 became the first spacecraft to travel near Uranus and in 1989 swiftly passed Neptune. As the sole spacecraft to have traveled along this route, it has uncovered fresh data from locations more than 14 billion kilometers beyond Earth. The size of an old Volkswagen Beetle, these space probes have exceeded all expectations and continue to deepen our understanding of the cosmos. As the Voyager probes set out to study Mercury, Venus provided them with a gravitational boost, a method never attempted before. They became space exploration pioneers as a result. This was no simple assignment, though there was very little room for error. The outcome could be ascertained in a matter of minutes, and it sometimes required many attempts to get it correct. They had to go through the hazardous asteroid belt on their initial route to Jupiter, which brought them 10 times farther from Earth than Mercury, an issue that was much discussed in the 1970s. Luckily, Voyager had an easier time navigating this congested area because previous missions like Pioneer 10 and 11 had done so safely. However, Voyager still faced several difficulties. Let's investigate the far-off signals sent by Voyager to uncover mysteries from deep space. Voyager's journey into the unknown. The computers aboard the Voyager spacecraft had to be shrewd in order to handle all of the chores for their journey, as they had only 69 kilobytes of memory, which is far less than what your smartphone carries. They used an 8-track tape recorder to retain the data, and a transmitter as weak as a refrigerator light was used to relay it back to Earth. The spaceship used radio waves that traveled at the speed of light for communication. Its dish antennas measured 12 feet in width. However, communication was difficult since Voyager was billions of kilometers distant and expanding every second. For example, it took almost 18 hours for signals from Voyager 2 to arrive at Earth. Furthermore, it became increasingly difficult to distinguish the faint signals coming from the spacecraft due to the growing quantity of signals coming from Earth, such as those from TVs, radios, and mobile phones. The Voyagers have defied the odds and kept returning with startling new findings from the remote reaches of space in spite of these difficulties. Their research has altered and expanded our knowledge of the vast, uncharted regions beyond of our solar system. The Oort cloud, a location far away, is made up of ice particles that are kept in place by the sun's gravity. The Voyagers are gradually making their way toward this region, which extends nearly halfway to the closest star. Nearer to us, the heliopause, or edge of our solar system, denotes the point at which our galaxy narrows and the larger galaxy widens. Estimates of its distance before the Voyager spacecraft arrived varied greatly, but many believed it to be around 50 astronomical units distant, which increased support for the expedition. By providing us with close-up views of locations we've never seen up close, the Voyager's continued investigation helps us comprehend these far-off parts of space. However, these indicators were absent, which perplexed the experts. In particular, they were searching for a rise in cosmic rays, which are fast-moving, high-energy particles from supernova explosions and other high-energy events. This was not the case. Typically, a rise in these cosmic rays would indicate that the spacecraft had entered interstellar space. Rather, the heliosphere, a massive magnetic barrier that protects the inner solar system from external cosmic threats, was blocking the majority of the lower-energy cosmic rays. As the spacecraft got farther away, the crew keeping watch on Voyager also closely monitored any changes in the magnetic fields. It was anticipated that the charged gases in the interstellar medium, which is molded by the magnetic fields of neighboring stars, would have a distinct magnetic pattern from that of the heliosphere. However, no modifications were discovered, which further perplexed the investigators. Voyager 1 didn't begin returning intriguing data to Earth until it passed the heliopause, or edge of the heliosphere, which verified the predicted rise in cosmic rays. This incident demonstrated how unexpected and difficult space travel may be, while also providing significant new insights into what interstellar space is actually like. Remarkably, there was no indication of any shift in the magnetic fields surrounding Voyager 2. When traveling from an area of space shaped by the magnetic influence of the Sun to one influenced by other stars, people commonly believed that the magnetic field would change direction. Beginning its amazing journey towards the border of our solar system, sometimes referred to as the interstellar barrier, in November 2018, Voyager 2 arrived at the heliopause, which is situated 120 astronomical units, AU, from Earth. Its duplicate had arrived at the same location 6 years prior. To further complicate matters, Voyager 2's failure to find any variations in the magnetic field defied accepted ideas. Next, we investigate the mysteries that challenge our current understanding near the frontier of our solar system. Examining the limits of the heliosphere, scientists predicted that the heliosphere will contract and expand like the solar wind due to the Sun's 11-year activity cycle. Nevertheless, given that the solar wind was very powerful at the time Voyager 2 landed, none of the existing hypotheses could account for the peculiar findings. Given this intensity, the heliopause ought to have been located more than 120 Australian dollars from Earth. The Voyager probes detected slight variations close to the heliopause, which were brought on by heliosphere-to-heliosphere interactions as they approached interstellar space. However, the magnetic field appeared to be quite steady when viewed across longer distances. This discrepancy gave rise to discussions about whether our existing models were accurate or if the spacecraft will ultimately escape these chaotic areas and locate the genuine interstellar magnetic field. While some scientists believe the Voyagers may still be inside the heliosphere, Others say they have begun to reach interstellar space because of the probe's observations of a substantial rise in galactic cosmic rays and plasma density. Expert debates have been sparked by this new data, which tackles one of the major issues facing space exploration right now. It's similar to attempting to view an entire room via a fishbowl when trying to comprehend the heliosphere. We need a probe that can observe the solar system from a great distance in order to fully comprehend it. Sadly, despite the fact that we no longer use antiquated technologies like answering machines and VCRs, the Voyager spacecraft continues to operate successfully in spite of all odds. They are employing software that is quite primitive and technology that is more than 50 years old. Rather than utilizing intricate coding, the initial developers kept things simple. Voyager 1 has 4 operational instruments now, whereas Voyager 2 still has 5. An apparatus that transforms heat from the radioactive decay of plutonium into energy powers this spacecraft. Nonetheless, NASA must choose which systems to continue operating in order to conserve energy because they lose around 4 watts of power a year. The heater for the cosmic ray detector, which is essential for determining when the spacecraft leaves the heliosphere, had to be turned off by engineers just 3 years ago. Since it's considerably colder out there than it was intended to withstand, it's amazing that it continued to function when everyone else anticipated it to break down in the extreme cold of space. Because they are located within the spacecraft's main body, where heat from the computers keeps the temperature higher, the magnetometer and the plasma science instrument will probably be the last to shut down. Every other instrument is situated on a 43-foot fiberglass boom, leaving it open to the elements. But the difficulties don't end there. With all things going according to plan, we might be able to continue using the Voyagers until 2030. Power is the main problem. The nearest star to Earth, Proxima Centauri, will be passed by Voyager 1 in around 16,700 years. It will be followed 3,600 years later by Voyager 2. They will continue to circle the Milky Way for millions of years after these encounters, long after the Sun and heliosphere have vanished. These sturdy spacecraft will outlive Earth, and who knows, they may even send out one last message that no one will be around to hear. The Voyager's tale is proof of our curiosity and our fervent desire to explore. Titan IIE/Centaur rockets carried the Voyager 1 spacecraft into orbit. Voyager 2, its twin, had likewise been launched into the universe on its own trajectory just 15 days prior. The primary goal of these 2 spacecraft was to investigate Jupiter and Saturn, the 2 largest planets in our solar system, as well as their moons. However, they accomplished far more than anyone had anticipated. The Voyagers traveled further from Earth than any other man-made object, going much beyond the scope of their first mission. They even ventured into interstellar space, a region of our galaxy never previously visited by spacecraft. Currently, Voyagers 1 and 2 are nearly 12 billion miles away from Earth and are still sending back data that astounds scientists. Recently, they have discovered strange occurrences. Come along with us as the Voyagers pass by massive planets and uncover new marvels. Decades of unanswered alien questions. We've been continually shocked by this twin spaceships. They began by investigating the moons of Jupiter and Saturn more than 40 years ago, which altered our preconceived notions about them. These moons proved out to be lively and energetic, not like our own drab bodies covered with craters like our own moon. Being the sole spacecraft to explore these far planets, Voyager 2 made history in 1986 when it became the first to sail by Uranus and Neptune. NASA has devised strategies to sustain these spacecraft while they carry out their extensive exploration. They want to keep the Voyagers running until at least 2030 by conserving energy and shutting off components that aren't needed. Particularly in light of a recent and unexpected finding from outer space, the NASA team continues to follow these amazing explorers with a mixture of pride and nostalgia. The tremendously rich data that Voyager 1 and Voyager 2 returned has sparked new enthusiasm in space travel and led to several significant discoveries. Built to last, these spacecraft have successfully traveled into space, capturing crisp photographs and comprehensive data. The scientific community was already intrigued by the images they returned with of far-off worlds before they ever made it to the outer planets. The crew at NASA's Jet Propulsion Laboratory was ecstatic to see the first photographs of Jupiter's whirling clouds and the renowned Great Red Spot when Voyager 1 began delivering images of the planet. The great surprise, though, was when they looked at Io, Jupiter's moon. Io, a moon that is marginally larger than Earth, has been discovered to be the solar system's most volcanically active body. Unusual signals from Io were picked up by Voyager 1, and the photos revealed powerful volcanic explosions that were launching debris high into space. Pele, one of Io's volcanoes, erupted spectacularly, sending plumes across an area almost as big as France and reaching heights higher than Mount Everest. Over 33,000 photographs of Jupiter and its moons have been obtained by the Voyager spacecraft, collectively showcasing both the planet's breathtaking majesty and the moon's varied landscapes. However, the amazing findings made by these two spacecraft were only getting started. Even though Jupiter's rings aren't as brilliant as some others, it was unexpected to realize that it had them nonetheless. Jupiter is now much more intriguing in light of this finding. Another surprising development was the discovery by the Voyager 2 spacecraft that Europa, one of Jupiter's numerous moons, is submerged almost 60 miles below the surface in a thick coating of ice. This led to a re-evaluation of previous space theories by scientists and renewed interest in the possibility of life on ice moons like Europa. Utilizing Jupiter's gravity to accelerate the Voyager spacecrafts was a vital maneuver that enabled them to move away from the Sun and toward Saturn. Voyager 1 approached Titan, the moon of Saturn, which is encircled by a dense orange cloud. This prompted a closer examination of Titan's intricate atmosphere. Following this interaction, Voyager 1 departed our solar system. As all of this was going on, Voyager 2 continued its amazing investigation. In 1986, it passed by Uranus and discovered 11 new moons. When it arrived to Neptune 3 years later, it unveiled the dynamic and intriguing features of this far-off ice giant, including the recording of the fastest winds yet seen in our solar system, winds that might approach 1,000 miles per hour. Voyager 2's approach to Neptune, which was reached in just 2,980 miles, provided startling new information about this distant planet. Triton, the biggest moon of Neptune, with temperatures as low as -391 degrees Fahrenheit, making it one of the coldest locations in our solar system. In addition, Triton featured active ice volcanoes that erupted into a thin atmosphere, spewing icy particles and nitrogen gas. These findings brought to light the variety and allure of the planets inside our solar system, including those closest to it. Notable scientist Carl Sagan was a major force behind the advancement of this space project. His contribution to the Voyager project was significant, and he was particularly keen to get a last batch of pictures of our solar system as a farewell present to the human race. When Voyager 1 rotated its camera back towards the inner solar system on Valentine's Day in 1990 and captured 60 photos, his perseverance paid off handsomely. The most well-known of them, dubbed the pale blue dot, was captured at an astounding 3.8 billion kilometers per hour and depicted Earth as a small, insignificant blue dot in the expanse of space. The Voyager missions are still sharing knowledge from space decades later. The art of gravity assist. Even after 40 years, these spacecraft continue to return useful information from far beyond space. It's interesting to note that the Voyager probes use an outdated 8-track cassette technology, which was widely used in the 1970s. This demonstrates the mission's designers' astute preparation, since they selected robust and dependable technology. These tapes include vital scientific information on planets, moons, and the interstellar medium, providing answers to some of the deepest mysteries of the cosmos, in contrast to ordinary cassettes that played music. What's even more astounding is how these spacecrafts managed to carry out their job in spite of enduring harsh circumstances, including dramatic temperature changes, space radiation, and the utter nothingness of space. It's similar like sending your grandparents on an Antarctic adventure and witnessing their successful and survival. The Voyager mission's deft use of gravity assist maneuvers, which successfully slingshot both Voyager 1 and Voyager 2 far into the solar system, allowing them to continue their arduous voyage through space, is responsible for their amazing durability. This is when gravitational slingshots, or gravity assistance, come into play. It can be compared to a cosmic dance. These spacecraft interact with some of the larger planets in our solar system rather than relying only on their own power. Through the utilization of these massive planets' powerful gravitational pull, the spaceship is able to propel itself farther into space. They may travel farther than they normally could and conserve gasoline by using this strategy. Imagine the giant planet Jupiter, which has a tremendous gravitational pull, is being approached by the Voyager 1 probe. Voyager 1 was expertly piloted by the talented scientists at NASA's Jet Propulsion Laboratory to pass Jupiter at precisely the correct angle and velocity. Jupiter's gravitational pull on Voyager 1 caused it to accelerate dramatically as it approached, much like a turbo boost in space. Here's where it gets challenging, though. This move calls for extreme accuracy. Voyager may first have drifted off course and perhaps ended up in tragedy if the estimates were incorrect. Fortunately, the NASA crew carried it out flawlessly, and these planetary encounters were a great success. It is rather amazing how precise these procedures need. The talented group of scientists and engineers accomplished this on several occasions throughout several missions, not just one. Both Voyager 1 and Voyager 2 were able to set out on amazing solar system trips because of these gravitational aids. For instance, Voyager 2 was able to reach Uranus and Neptune thanks to speed increases from both Jupiter and Saturn. The Grand Tour, which would not have been feasible without these gravity assistants, would not have been possible without these moves. Because to the well-thought-out gravity aids, the Voyager missions were a great success, with Voyager 1 even making it to interstellar space, and Voyager 2 following quickly behind. Although the concept of gravity aids is straightforward, its implementation is far from easy. Voyager 2's Grand Tour necessitated extraordinary precision throughout. The mission may have been jeopardized by any inaccuracy in the time or angle of these enhancements. But the crew had to overcome other obstacles as well. During these movements, they also had to make sure they collected as much scientific data as possible. Astronomers and physicists were able to explore more of space since they gained extensive knowledge on how gravity helps with their job throughout time. They went on to develop the Deep Space Network as a result of this. What do you think? Could we employ gravity assistance to go to places outside of our solar system in the hopes of finding extraterrestrial life? Like, comment with your thoughts, and don't forget to subscribe for more.